Bigfin squid. The deep ocean begins where sunlight gives up, roughly 200 meters down, and then continues for another 10,000 meters of nothing. No light, no landmarks, almost no footage of anything that lives there. The bigfin squid has been captured on camera fewer than a dozen times in recorded history, and every single time, the reaction from the researchers watching the footage was identical. A long pause, followed by the kind of silence that means nobody has the right words yet. Its body is small and nearly transparent. Its arms are short, but from each arm extends an impossibly long filament, thin as a loose thread, reaching up to 8 meters outward in every direction, hanging in the water like something that was carefully assembled and then abandoned before anyone decided what it was for. What those filaments do remains unknown. They might snare prey. They might detect vibration. They might serve a purpose that our existing framework for understanding animals simply doesn't have a category for yet. The bigfin squid drifts at depths approaching 5,000 meters, arms wide open in complete darkness, looking less like an animal and more like a warning that something left behind. Goblin Shark. Most sharks converge on the same design. Fast, streamlined, built around forward motion. The goblin shark received different instructions. It is pink, not softly, not flatteringly, a fleshy, semi-translucent pink, because its skin is thin enough that the blood vessels underneath show straight through it. From its face extends a long, flat rostrum, lined with electroreceptors that read the electrical fields of nearby prey in total darkness. And when it locates something close enough, its jaw physically separates from its skull and launches outward, a hinged structure that extends several centimeters beyond its face in a fraction of a second. Scientists call this slingshot feeding. The goblin shark, to the extent it has an opinion, appears unbothered by the terminology. It lives almost entirely below 300 meters, which explains why most people have never encountered one, and those who have tend to describe the experience less as a wildlife sighting and more as something they are still quietly working through. Anglerfish. The anglerfish has somehow achieved genuine fame despite, or perhaps because of, looking like something assembled from leftover parts at the end of a very long shift. The female carries a bioluminescent lure on a spine above her head, a cold, slow pulse of light in absolute darkness, designed to attract whatever's curious enough to move toward it. Anything that does move toward it learns, very briefly, that this was an error. But the female is only half the story. The male enters the world without a functioning digestive system. His sole biological purpose is to find a female, bite into her skin, and fuse permanently. His circulatory system merges with hers. His organs dissolve. He becomes a small reproductive structure attached to something vastly larger and more dangerous than he ever was on his own. Multiple males can attach to a single female simultaneously. Researchers didn't discover this through deliberate investigation. They noticed that female specimens kept arriving in their nets with strange, unidentified lumps on the body. Those lumps, examined more closely, turned out to be males, former males, still technically males in the structural sense, but committed now in a way that leaves very little room for independent thought. Vampire squid. The name sets expectations the animal then exceeds in entirely the wrong direction. Wrong meaning stranger, not more frightening. The vampire squid is not actually a squid. It is the sole surviving member of its own distinct order, a lineage so old it sits between squid and octopus without belonging clearly to either. It lives between 600 and 900 meters down, inside what oceanographers call the oxygen minimum zone, a band of water so depleted in dissolved oxygen that essentially nothing else is willing to occupy it. Its body runs from dark red to complete black. Its eyes are proportionally the largest of any animal on Earth. When threatened, it doesn't flee. It folds its webbed cloak upward over itself, becomes a different shape entirely, and holds still. It doesn't hunt. It collects marine snow, particles of dead organic matter drifting down in a slow, continuous rain from the world above. The vampire squid didn't end up in the oxygen minimum zone by misfortune. It assessed the situation, found the zone acceptable, and has been there ever since. Animals designed by a darkness so complete that most life never survives long enough to understand it. Does that stop you the way it stops me? This is exactly what this channel is built around. Subscribe now and don't miss what's already coming next. Giant isopod. The giant isopod is what happens when you take a woodlouse, give it 160 million years of deep-sea evolution, and remove everything that was ever associated with urgency. It reaches 45 centimeters in length, moves slowly, and carries itself at depths up to 2,500 meters. with the composure of something that has genuinely never encountered a situation it considered worth rushing. Giant isopods can survive without eating for more than 4 years, not weeks, years. They wait on the seafloor for whatever the ocean above eventually discards. Whale carcasses, dead fish, anything. When nothing comes, they continue waiting in the same posture with no visible distress. One individual in a Japanese aquarium refused every meal for 5 years and 8 months before dying, and the researchers caring for it were never entirely sure whether something was wrong with it or whether it simply preferred things this way. The giant isopod has not changed meaningfully in 160 million years. Whatever arrangement it worked out with the deep ocean when the dinosaurs were still alive, it kept. It will almost certainly still be working when the next thing above it goes extinct. Frilled shark. The frilled shark looks like a mistake, moves like a serpent, and belongs to a lineage that was already ancient when the Cretaceous ended. It grows to about 2 meters, navigates the water in slow undulations that look nothing like any other living shark, and carries 300 teeth arranged in 25 rows, each one trident-shaped and curved inward, engineered so that whatever enters the mouth finds no route back out. When it strikes, it coils and lunges forward, fast in a way that nothing about its general movement prepares you for. The frilled shark was formally described by science in 1884. In the 66 million years before that, it conducted itself in essentially the same manner at depths up to 1,500 meters, entirely undisturbed by whatever was reorganizing the surface world above it. It didn't survive the mass extinctions by adapting. It survived them by not noticing. Gulper eel. The gulper eel does not look like an eel in any sense the word usually implies. It looks like a jaw, a large, deeply committed jaw, that evolution attached a body to as a secondary consideration. That jaw can hinge along its full length and open wide enough to swallow prey significantly larger than the eel itself. A practical solution to an environment that offers very few meals and no opportunity to be selective. The body behind the jaw is scaleless, nearly without muscle, and not built for speed. The gulper eel does not chase. It holds its mouth open and moves forward through the dark, functioning less like a predator and more like a slow-moving consequence that something is about to swim into. At the tip of its tail, a small bioluminescent organ pulses quietly in the dark, drawing prey toward the light and toward the jaw waiting at the other end. Everything the gulper eel is has been organized around a single event, the moment the mouth closes. Barrel-eye fish. The barrel-eye fish has a transparent head. This is not a rhetorical choice. It is a description of its literal anatomy. The dome above its face is clear, fluid-filled tissue, and through it, visible like instruments behind a cockpit window, sit 2 large tubular eyes, bright green, oriented upward, scanning continuously for prey silhouettes passing against the faint light filtering down from above. For decades, scientists believed those eyes were fixed permanently upward. Underwater footage eventually showed they rotate, pivoting forward inside the transparent dome to track prey once it comes within range. The dome is thought to protect the eyes from the stinging cells of siphonophores, which the barrel-eye trails closely, stealing prey they have already paralyzed without triggering their defenses. A see-through skull, rotating eyes, a hunting strategy built entirely on following something dangerous and quietly taking what it catches. The deep ocean keeps producing animals that, once properly understood, make you want to sit in a quiet room for a while and think carefully about what else might be down there. A jaw with a body attached as an afterthought, a fish whose skull you can see straight through, a squid filmed fewer than a dozen times and still not understood. If this is the kind of thing that pulls you in and doesn't let go, this channel was built for exactly that. Subscribe. There's considerably more of this on the way.